right. So all of you, or at least most of you, should have had your first workshop already. I gather there were quite a few of you who had trouble getting access to the system servers. I'm told that that problem is fixed. Has anybody who didn't get connected earlier tried since yesterday? Well, since last night? Anybody have any luck? Sorry? It works now. Okay, good. So if you still have a problem, there's an announcement on the LMS with a link to where to go to submit a report, and they'll straighten it out for you. Sorry for that little snafu. We've had some changes to the system hardware arrangements, and that led to some problems. And the other issue is the first assessed lab is due at the end of next week, a week from today, at 5 p.m. This lecture will help you with that to some extent, and some of the sort of quick coding I did at the end of the last lecture should have also given you a hint. Anyway, read the spec carefully. Allow enough time for you to submit it and get your feedback, and correct any errors in it. Also, check the LMS for an announcement, also with a link or with a pointer to a document that tells you how to interpret the feedback that you get when you submit. Okay, so the feedback tells you essentially what you've done wrong, and hopefully that allows you to fix it, correct the problem and try again. Again, you can submit as many times as you want. All right, so the topic for today is mostly about input-output, but we're going to start off with a few sort of easy topics. So for the number types, we have a bunch of operations. So that when you think about it, for any given type, the most interesting thing about that type is what are the things you can do with that thing? What are the operations you can perform? So for the integer types, for all six of the, the number types. For all six of the number types, we have just the standard operations you'd expect: plus, minus, times, divide, and percent sign means modulo, or the remainder on division, if you like. When you apply an operation, any of these operations, the two operands have to be the same type. So you can add an int and an int, you can add a byte and a byte, and so on. And all of these operations return the same type as the two inputs. So you add two ints and you get an int. If you divide two ints, if you divide, say, 5 by 2, you're going to get back an int. So 5 goes into 2 goes into 5 2 times with a remainder of 1. So the quotient is going to be 2, not 2.5. I'll talk a little later about what you can do to fix that, to work around that, if you really do want to get 2.5. So you can use these operations, nest them as you're used to, 2 plus 3 plus 4 plus 5, apply multiple operations, and that allows you to construct an expression. And an expression has a value, and your program will manipulate that value. So what can you do with expressions? Well, you can apply them, pass them as as arguments to other operations, including, like here, 2 plus 4, we're applying as the left operand to this star. We can also, so that whole thing is also an expression, and we can assign it to a variable. There are also the comparison operators, basically what you'd expect. Less than or equal to, greater than or equal to. Equal means is an equality comparison. A single equal is not. A single equal is an assignment, like we just did here. So keep those two straight. If you try to use equal as a comparison, it's not going to work. You need equal. And bang equal, exclamation point equal, it means not equal. And I suppose you can kind of, if you sort of squint and cross your eyes just right, you can kind of see that bang as a slash through the equal, to mean not equal. I don't know. Use your imagination. And all of the comparisons return Boolean values, not numbers. You can't use a number as a Boolean, and you can't use a Boolean as a number. They're completely distinct. So if you're familiar with other languages like C, for example, doesn't have Booleans. You just use a number. 0 means false. Anything else is true. That's C. You can't do that in Java. Okay, so what are the operations on Booleans? Well, if you know C, they're the ones you're familiar with. And 2 ampersands is conjunction. So and is true when both of its operands are true. Or if you like, it's false if either of its operands is false. The pipe, 2 vertical bars, is disjunction, is or, and that's true if either of the operands is true, and it's false if both of the operands are false. But note that these 2 operations are short-circuit operations. That's the word we use for it. What that means is it doesn't do any more work than it needs to. If I want to know if A and B are both true, well, I need to look at A. But if A is false, then I know that it's not the case that A and B are both true. I can tell you right then, if A is false, A and B is false. I don't need to look at B at all. And that's useful for efficiency purposes, but it's also useful for correctness purposes, for avoiding errors. So for example, you might say dx not equals 0 and dy over dx is greater than 0. So if dx is 0, then that test will fail, and then the whole conjunction will fail. If it didn't, if we went on and evaluated the right-hand side when dx is 0, then we'd be dividing by 0 right there. And your program crashes. You get an exception, and your program crashes. Okay, so the short-circuit operations are useful for that sort of thing. That's a very typical sort of case of where you'd want to use it. And also, likewise, it can be more efficient. You can avoid doing some complex computation as the second thing. So if you're trying to ask if 2 things are true, one sort of rule of thumb is to put the cheap one, the inexpensive test first and the expensive test second, if there is one. Now, once in a great while, you'll want a version of and or, that always evaluate both arguments. And the reason you might want to do that is if both arguments have some sort of side effect, or at least if the second argument has some kind of side effect. I could make up a case, but we haven't come to enough to do it. And as I said, it comes up very rarely. But if you want that, there's a single ampersand and a single vertical bar version of and and or. They mean the same thing, except they always evaluate both arguments, and then they give you the same result. There's the exclamation point by itself. That's just negation. It's just not. So, and not of something is true if and only if its operand is true. It's false if it, sorry. Not of something is true if its operand is false, and it's false if its operand is true. It's just not. So you might say something like not test 1. Okay. So now the types we've talked about so far are were primitive types. All the number types are primitive types. String is not a primitive type, but I'm talking about it now because A, you use it all the time, and B, because we have this double quote syntax. You can just write a string in your program. So maybe that's part of why we use them all the time. Anyway, they're in the library. They're not built into the language, but that's not a tremendously significant distinction. Anyway, so we've got them. So what can you do with a string? Well, first of all, you can, as I said, specify a string with the double quote syntax. So a string begins with a double quote character and it ends with a double quote character. And then the question you should be asking yourself is, what if I want to put in a double quote character inside the string? Then what do you do? Well, Java has a solution for that. You can do that. And what you do is you precede the double quote character, the double quote character that you want to put in the string rather than have it end the string. You put a backslash before it. So backslash double quote really just means a double quote character inside your string. And now the question you should be asking is, well, what if I want to put a double quote character in my, a backslash character in my string? Well, and the answer to that is you put a backslash before that. So here's a somewhat artificial example. So here's a string, he said, and then backslash double quote, backslash, open paren, backslash, backslash, close paren, is special. Exclamation point, backslash double quote, double quote. So that final double quote ends it, because that's the first double quote after this one that's not preceded by a backslash. The string that this means doesn't have that backslash in it, doesn't have that backslash in it, and doesn't have that backslash in it. So there's only one backslash in the actual string. But we've written 3 backslashes in it to protect 2 double quote characters and a backslash. Okay, is that clear? It's kind of hard to say these things. Maybe it's worth showing. Oh, let's see if I can. No, I can't. Not going to let me select it. Okay, well, anyway, so here was my example from, did I do this? No, I didn't do this. This is something else. So let's do system.out.println. And I'll put that string in it. There's a double quote, backslash, double quote. Oh, no, wait. Was he said, oh, I can't look at it now. He said, I can't remember what he said. Backslash is special. Okay, got it. He said, backslash is, oops, no, well, okay, special. and then exclamation point, backslash, double quote. And I didn't get it. Backslash, double quote. Here's my double quote. And then I wanted like that. All right? I think that's right. And now let's try running it. Oops. I missed a space. Try it again. Okay, so anyway, I know it's tiny. I haven't figured out how to make this part bigger. But, yeah. Okay.
How about the square brackets next to the string in the input for the name?
Here,
Yeah.
let's say that's our little secret for the next 4 or 5 weeks. So basically, what I'm suggesting is to treat all of this as boilerplate. Every character in it is going to be explained, but I'm not ready to do it yet. And this will be one of the last things I actually explain. Those brackets. Okay, so in addition to protecting backslashes and double quotes, backslash has another function. If you follow it by a letter, by certain letters, it has a special interpretation as special characters that are hard to write in your actual file. So for example, backslash n, that's the most common one. That just says start a new line. So if I do, say, that, and now run it, you can see that the output comes out on 2 lines. So the backslash n just starts a new line, and it doesn't show up as a backslash n in the output. Okay, so that's the one you use most often. There's also backslash r, which is a return without a line feed. Yeah, this goes back to teletypes, controlling teletypes, 80 years ago. But in any case, what this does is it takes you back to the beginning of the current line without going down 1 line. So it allows you to overwrite the current line. Once in a while, that's useful. Backslash b is a backspace, a single backspace. So you can write something out and then backspace and overwrite it. Probably not all that useful. Backslash t is a tab character. Any of these are characters that you could put in a file. But yeah, like I said, backslash n is the one people use most often. And all of these, by the way, work in character constants. I haven't really talked about characters. There's not that much you can do with a character, except put it in a string or take it out of a string. But the way you can specify a single character as a constant in your code is to put single quote characters, a single quote before it and a single quote after it. So single quote backslash n, single quote, is the new line character by itself as a single character. Okay. Again, you don't need single character constants all that often in your Java code. Okay. So other string operations. Actually, there's a ton of string operations. A very commonly used one is plus. So we've already used it in some examples. But you can use plus to concatenate 2 strings together. Just shove them together. So if you say system.out.println hello with a space plus world, it'll print out hello world. Just shoves the two strings together. But plus is smarter than that. Maybe, I think there's a fair argument that maybe it's too smart for its own good. But in any case, it's smarter than that. So if you have two integers and you do plus, you add the two integers together. If you have two strings and you do plus, it concatenates the two strings together. If you have a string and an integer, then it will turn that integer into a string and concatenate that with the string. Okay? So it's kind of handy. So let's do something completely different. Number is numbered? No. Your number is, and then plus 2. And so that's 2 as a number, not 2 as a string. In fact, let's make it a little more interesting. I'll say int number equals 2, and then I'll say your number is plus number. Numbers. I'm really insistent on that. And so now it'll say your number is 2. So what it's done is it's taken that integer and turned it into a string and concatenated it with the other string. And what if I do this? Oops. Oops, forgot space. But anyway, so if you have a plus and there's a number on one side and a string on the other side, it'll turn the number into a string and then append them together. So I've printed it out here, but I could have just put it in a variable, a string variable, and passed it around my program and done other stuff with it. It just creates a string. There is a little catch, though, which is, what if I say, one plus 1 equals plus 1 plus 1. So what do you think that's going to print? We don't need that anymore. What's going to happen when I hit this little go button? Sorry? Oop. Oh yeah, forgot about that. Thank you. Well, I was going to have an error. Now I'm not going to have an error. So what am I going to have? Close. 1 plus 1 is 11. Well, it's not really 11. It's really 1, 1. Because plus works left to right. So I have this expression. And I have a string here, and I have a number there. And so what's going to happen? I'm going to turn that number into a string, and I'm going to concatenate them. 1 plus 1 equals 1. Now I have the string 1 plus 1 equals 1 plus 1. So what's going to happen? I'm going to turn that 1 into a string. And I'm going to have 1 plus 1 equals 1 with 1 stuck on the end. Okay? So this is where maybe Java's being actually a little bit too clever for its own good. What I can do to fix this is put parentheses around it. So I just use parentheses for grouping, just like you do in algebra. And now it says I've got a string plus an integer. The integer is 1 plus 1, which is 2. And so now it does what presumably I wanted it to do. Okay, questions on that? Okay. So anyway, there's the answer. Put parens around it. Okay, so as I said, strings are a class, and what you'll find is that the primitive types have very few operations. Plus, minus, times, divide, less than, greater than. Well, there's a handful of them. But the classes tend to have a lot more operations because they don't have to use funny characters on the keyboard. They can actually use names for things. So the string class has an enormous number of methods, an enormous number of operations. So the operations on a class are called methods. So the string class has an enormous number of methods. These are just a few of them that I think are probably the most likely to be useful to you. But what I do recommend is looking at the documentation. And in fact, it's easy to do that. In fact, I'll just show you. So if I just Google for Java string class, and I don't even need to do uppercase, top hit is it. That's the documentation for Java 7 string class. And, well, you see the size of that little scroll bar? That gives you an indication of how many methods there are. Okay, so I'm not going to list them all. I'll just show you a few of the useful ones, the most useful ones. Assume we've got S and S2 as string variables, and what is it, I and J as integer variables. Okay, so given those variables, then we can say S.length, open paren, close paren. That's not optional. You have to have the empty parentheses. Looks kind of silly, but you got to do it. S.length with empty parens gives you back the length of the string, how many characters there are in the string. S.to upper, to uppercase. I always get that wrong. S.to uppercase, where the U and the C are uppercase. It takes whatever the string S is and makes all the letters in it uppercase. Other characters, numbers, punctuation and stuff are left alone. And there's S.to lowercase. That does the opposite. All the letters are made lowercase. S.substring is pretty useful. So S.substring I, comma J. It returns the substring. Now, be careful about this. This is a little weird. It's weird for a good reason, but it is maybe a little surprising. First of all, so it gives you a substring of the string starting from character I and going up to character J, except character I is numbered from 0. So you want to put in a 0 for the first thing if you want to start at the very start of the string. If you start at 1, you're skipping over the first character. And J is actually the character you stop before. Okay, so you go up to, but not including J. And you start from I, not after I, but from I. So it includes the first character and it excludes the last character that's identified here. Okay, so for example, if I take smiles, substring 1 to 5, well, 1 is the M, and 5 is the S at the end. 0, 1, 2, 3, 4, 5. So S is number 5, but it goes up to but not including that. So it's mile. Okay? The way to think about this is if you take that number and subtract that number from it, that tells you how many characters you're going to get. Okay, so 5 minus 1 is 4, so the string is going to be of length 4. The other reason for doing that, probably the real reason for doing that, is it lets you, when you're coding, you could take a string and break it up into, say, groups of 4 by starting at 0, and you say 0 to 4, and then you say 4 to 8, and then you say 8 to 12, and 12 to 16. You don't have to say 0 to 3, and 4 to 7, and 8 to, you see what I'm saying? You get to reuse the same number. So it actually works out to be useful to do it that way. It's probably a good design. Okay, so that's substring. The next one is equals. If you want to compare two strings to see if they're equal, you have to use equals. You can't use double equal sign. And here's the real gotcha. This is definitely an accident waiting to happen. This is, your gun pointed squarely at your foot. All right? Very easy to shoot yourself in the foot because equal equal does work on strings. It just doesn't do the right thing. It doesn't tell you whether or not the strings are equal. It tells you something else, which I'm not prepared to explain just now. In a few lectures, we'll cover it. Like I said, to really understand Java, you have to know all of it. If you knew all of it, then I could explain it to you. So we're doing it a little bit at a time. Of course, if you knew all of it, I wouldn't have to explain it to you. That's the catch, isn't it? Anyway, so don't use equal equal to compare two strings for equality. And in fact, we'll see that that goes for objects in general, not just strings. And then finally, s dot index of s2 says, look in the string s and find the first place you can find the string s2. So if s is smiles and s2 is le, then it's going to give you the integer position, which is 0, 1, 2, 3. Okay, so that's quite useful in analyzing a string and looking for things. And in fact, comparing or combining index of together with substring is quite useful. You can find a string and then take the stuff before it and the stuff after it. Do with it whatever you want to do. Also, you shouldn't use less than or greater than or equal to or any of those comparison operators on strings. Again, they don't do what you think they do. Yeah, okay. All right, so we saw we use equal for assignment. Java throws in some handy convenience operations because it turns out that you write things like x equals x plus 1 all the time, x equals x times 2, that kind of thing. That just shows up over and over again in your coding. And so Java gives you a nice little shortcut for saying, you kind of want to think about this as something different. X equals x plus 1 is different than saying x equals y plus 1, isn't it? You say x equals y plus 1, it says, well, take y, add 1 to it, and let's call that x. If you say x equals x plus 1, you really want to think about that as add 1 to x. It's a different kind of thing. So it's useful to have a different syntax so you don't have to mention x twice. So the syntax is pretty straightforward. Whatever that operation is, you take the x, throw it away, and take that operation and stick it before the equal sign. Okay? So if you want to say x equals x plus 1, instead you can just say x plus equal 1. X equals x times 2, you can write x times equals 2. X minus equals 2. X divide equals 10. Even x percent equals y. You're probably not going to do that very often, but hey, I've seen it. You could do it. It also works for the vertical bar and the ampersand, but not double vertical bar or double ampersand. And by the way, you can use plus equals on strings as well as numbers. So that's quite handy. You know, you've got a string message, and then you can say message plus equals world, and then print it out. Okay. Now, while we're talking about special versions of operations, Java goes one step further. In the special case of x equal x plus 1 or x plus equals 1, there's an even shorter version, which is x plus plus. And there's also a shorter version called plus plus x. But the thing about them is they're different than x plus equals or x equals x plus something. Those x plus equals and x equals x plus, those are statements. You use them at the statement level, and it says, here, do this for me. And you go on to the next statement and do that. Plus plus x is an expression. That means it has a value. So you can say something like plus plus x plus 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 x. And yes, you actually can say that. As confusing as it might be. In fact, it is very confusing. In fact, if you said plus plus x minus plus plus x, that's even stranger. But anyway, so plus plus x has two roles. It does two things. One is it has a value, and the other is it changes x. So there's plus plus x, and that's called a pre-increment operation because the plus plus shows up before the variable. And what that says is add 1 to x and return that value. Return the value of the new x. So it does two things at once. Can be kind of handy, but I'm about to tell you not to use it. And then minus minus x is the same sort of thing. You subtract 1 from x, and then whatever that is, that's the value. X plus plus also adds 1 to x, but it returns the value of x before adding. So it's a post increment. You get the value, and then it adds 1 afterwards. So you get the value before 1 has been added. And likewise, x minus minus, you get the value before 1 has been subtracted. Okay? As I said, it can be pretty confusing. If I say something like plus plus x minus plus plus x, which plus plus happens first? You know, let's say x is 7. Then plus plus x is 8, and x is 8. And the other plus plus x is 9. And now x is 9. But the question is, which one came first? So is the answer plus 1 or minus 1? In the case of Java, there is a right answer. I'm not positive, but I'm pretty sure the answer is going to be minus 1. If somebody's got a computer, you can try it. But really the point I'm making is, man, that's confusing. So don't do that. Um, well, I'm going to skip over this. You can actually work this one out. Actually, no, I won't skip over. Well, now I've blown it, haven't I? Okay. Well, the answer is 4. So why is the answer 4? X was 10 and Y was 5. So X plus plus, what's the value of that? Exactly. It's 10. So afterwards, X is 11. But in terms of the value, it's just 10. And plus plus X, what's the value of that? Sorry, plus plus Y, I'm sorry. Yeah. So Y is 5, plus plus Y is 6, and now Y is 6. So after this, X is 11, and Y is 6. But the value of this is 10. The value of that is 6. So 10 minus 6 is 4. And that's why 4 is the right answer. But really the point of this is it's confusing. So don't do that. It's very simple. See, the other alternative, you could always just use X plus equals 1 as a statement, or X minus equals 1 as a statement, and you put it where you want it. If you want a pre-increment, then you put it before the value. If you want a post-increment, you put it after you use the value. It's all really straightforward, and it's very obvious when you're reading the code. It's very clear. But again, Java goes one step further, and it lets you use plus plus X or X plus plus as a statement. So instead of saying X plus equals 1 and then use X, you can just say plus plus X, semicolon, and then use X in the next statement. Okay? In that case, though, what's the difference between plus plus X and X plus plus? In terms, as a statement, there is no difference. They both mean increment X. The only difference between the two of them is when you use it as an expression. Then in one case you get the value before you've incremented, the value of the variable before you incremented it. In the other case you get the value after you've incremented it. But if you're just using it as a statement, you're ignoring the value. So that doesn't matter. So in that case, both of these mean exactly the same thing. And it's really just kind of a matter of taste which one you use. What I recommend is, if you're using this as a statement, pick one and use it throughout. Otherwise, it's just confusing. So that's my recommendation, is go ahead and use this if you like, in preference to X plus equals 1. But use it as a statement. And then just use one of them. And likewise, minus minus X or X minus minus. Okay. So, earlier on I said if you've got 5 and you've got 2 and you want to divide them, and these are integers. You've got 5 as an integer and 2 as an integer, and you want to divide them and you get 2.5. Well, as I said, if you take 5 divided by 2, you're just going to get 2. What you need to do is convert the 5 and the 2 to floating point, either to floats or doubles, preferably doubles. So Java, well, there's sort of two sides to this. One is you can get Java to do that for you. You can tell Java, please convert this into a double, or convert this byte to a double. Well, the second thing is sometimes Java will just do it for you because it knows what you want. So if you've got a variable that holds a byte, and then you've got another variable that holds an int, and you put the first variable, you assign the second variable to the value of the first variable, well, they're not the same type, but Java can say, hey, look, any byte I can convert to an int, right? Any byte is a number between minus 128 and plus 127. And all of those numbers will fit in an int. So I can just throw it into an int and just do it. Why should I make the user, the programmer, you guys, go through the effort of saying, hey, do this conversion for me? So Java will do that automatically. And the way it works is what this picture says. So if you have a byte, Java will automatically convert it to a short if it needs to. And if you have a short, it'll automatically convert it to an int. And this means that if you have a byte, it'll automatically convert it to an int. And then it'll automatically convert an int to a long. It'll automatically convert a long to a float. And it'll automatically convert a float to a double. So you can take a byte and put it in a variable that's meant that, that's a double. And Java will just do it and do the conversion for you. No problem. And by the way, if you have a char, Java will convert it to an int and then so on. So you could convert a char to a double. Seems kind of silly, but if you were so inclined, you could do that. Okay. And that, by the way, is called a widening conversion. Because think about it this way. An int is, a byte is small. It takes up, well, 1 byte. You can widen the space it takes up by expanding it out to 4 bytes to an int. So that's called a widening conversion. The other way to think about widening is it widens the space of the range of values that variable could take on. Okay, so a byte only has 256 different possible values. An int has 4 billion different possible values. So you're widening the space, the number of values that can be expressed. There's also a narrowing conversion. What if what you've got is a double and you want to put it into an int? Well, that's not going to fit. But still, there's a range of doubles that would fit. I mean, 0 is a perfectly valid double, and I can certainly have 0 as an int. So it might make sense to do this. But if you want to do this, Java's going to make you tell it to do that. You have to be explicit. Java's not going to just blindly do this for you and possibly, break your program. You could have an enormously huge double on the range of 10 to the 300, and you try and put that in a byte, no, it's not happening. So Java's not going to do it automatically, but you can do it manually. And you can also do it manually going the other way when Java doesn't know it needs to do the conversion. So if I have an int sum and an int count, and now I want to compute the, so I've summed up a whole bunch of numbers, let's say test scores or something like that. I want to find the average test score. But I want it as a floating point number. So I add up all the test scores, and I wind up with an int, because the test scores are ints. And the count, of course, is going to be an int. It's just a counting number. Now I want to do the division. What I can do is I can coerce the the sum, the int sum, to a double. And then I can divide that by count. And then I can put it in a variable of type double. Now there's something else going on here that might be not quite so obvious. Remember I said division, or all of the operations, work on the same types on both sides. Now I've got a double on the left and an int on the right. So what happens? Why does this work? Exactly. It does an automatic widening conversion because Java says, well, I can divide a double by a double, and I can convert an int count to a double. So it implicitly puts double in parens before the count. And you don't have to write it. Java will do that conversion. But it won't do both for you because it doesn't know that it needs to. Okay? So this is probably the more common way to use a cast like this. You want to do a floating point operation, and there's a existing integer operation, and Java can't tell the difference. Typically, it'll be a division. So, okay. If I didn't put double there, then what would happen? Sorry?
You get an error.
No, you won't. It's not an error. It's going to do the division. Well, let's say the sum is 5 and the count is 2. It's going to do the division. It's going to get an int. Sorry? Did I say it wrong? If the count is 2 and the sum is 5, then you do the division and you get 2 because you're dividing two integers. So it's got an integer on both sides. It says, sure, okay, I can do integer divided by integer. Then I just do integer division. And what that means is it always rounds down. Always rounds down. 4.9 rounds down to 4. So this is 2.5. It rounds down to 2. So I get 2. And that's an int. And then, wait, now I've got to put it in a variable of type double. So what's Java going to do? It's going to do the widening conversion. It's going to get 2.0. It's going to turn the int 2 into the double 2.0. So if you didn't put this in, your program would compile and it wouldn't do what you're expecting it to. And you'd wonder, gee, that's an interesting coincidence. Why is it that the averages always come out something 0.0? So there's a bug waiting to happen. Okay, precedence and associativity. So whenever you have two or more operators connected together with no parentheses, there's a question of grouping. Where do the implicit parens go? So if I have two operators, whatever they are, so these just are stand-ins for whatever operations they happen to be. So if I have A dot B plus C, it could mean A dot B plus C, or it could mean A dot B plus C. And so which will it be? It depends on the relative precedence of dot and plus. Which operator takes precedence over which other operator? Okay, so if dot takes precedence, then you get the parens around the A and B. If plus takes precedence, you get parens around the B and C. As you'd expect, or as is conventional in algebra anyway, times has higher precedence than plus. So 2 plus 3 times 4 is 2 plus 3 times 4 is 14, rather than, 24. No, 20. Yeah, can't do math. And then the question comes up, what happens if you have two operators that have the same precedence? Now, of course, an operator always has the same precedence as itself, but operators like plus and minus have the same precedence as each other. So if you've got two operators that have the same precedence, then the question is associativity. Which way do they associate? So if you have A dot B dot C and dot is left associative, then it's A dot B dot C. And if dot is right associative, it's A dot B dot C. So you notice that minus associates to the left. In the case of plus, it's commutative, so it doesn't matter. But minus associates to the left. So if I say 3 minus 2 minus 1, you'd expect that to come out to 0. But if minus associated to the right, then it would be 3 minus 2 minus 1. 2 minus 1 is 1, so 3 minus 1 you'd get 2 instead of 0. Okay, so it doesn't matter. All of this basically to make you aware of the fact that it matters. And now I'm going to tell you it mostly just works the way you'd expect. Okay, so like I said, plus has lower precedence than times. Plus and minus have the same precedence. They're left associative. It basically just works the way you expect. But a good rule of thumb is, if you're writing some code and you think, ooh, scratch, now I can't remember, how does this one work? What's the associativity? What's the precedence? Just not sure? I'll look it up in the book. No, don't look it up in the book. If you're not sure, then whoever's reading your code is probably also not sure. Put in the parens. It's easy. It's easier than looking it up in the book. Okay? So I'm not real big on memorizing these vast tables of which things have which operations have which precedence and which associativity and so on. Nevertheless, here it is. So dot has the highest precedence. So this is from highest to lowest precedence. So dot has the highest precedence. That's method invocation. So system dot out dot println. That's the dot. That has the highest precedence. The next highest precedence is plus plus and minus minus. And the left one has higher precedence than the right one, or vice versa. I never remember, so I would never even do plus 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 x. So, or plus plus x plus plus. Can you imagine doing that? That would just be cruel. So unary negation has the next highest precedence. And then casting has the next highest precedence. And then times, divide, and mod have the next highest precedence. Then plus and minus. Then all the comparisons. Then the assignment and not equal. What happened to equal equal? I lost it. So that should be equal equal. That's a bug on my slide, sorry. Then equal equal and not equal. And then and has higher precedence than or. So if you have A and B or C, the and has higher precedence, which probably is what you want. And then the assignment operators have the lowest precedence. And those are right associative. Not that anybody really cares. Okay? So let's take a break there and start up in 5 minutes, and we'll go on to the next thing. We'll actually do the I/O. Sure. Yes, that should be equal.
All right. So I didn't quite grasp what you meant. Value and the actual thing that this represents. So it was 10 in the example that you gave, and you said you use the value instead of 11. It actually
So the value of x plus plus is the value of x. The value of x, because that's exactly right. Because the plus plus is on the right. So you take the x and then you do the plus. If the plus plus is on the right, you do the plus plus and then you do the x.
Oh, I see. So x plus plus
So after you do x plus plus, or after you do plus plus x, either way, x is 1 more. The difference is what is the value of it? So when x is 10 coming in, the value of that is 10. The value of plus plus x is because you do the plus plus. Then you
It's a way different way of thinking. So the result of this would be that because this is within an expression, you have
either way, the question is value. When you're going to go use it in some calculation like this, do you take the value before you add or after you add?
here, you have to think about it for just because it's really like this.
Yeah, because x is before the plus. Take x before you do. Sure. Yeah. Sorry? So what's happened here is the lines beginning with a minus sign mean that's what I expected. That's what I expected to see. The lines with plus are what you were indicating. There aren't any lines with plus, so your program didn't actually print out any. What you need is to actually not have any of these lines come out, and that means you have it right. So if you get it right, it doesn't say anything, it's just a when you see significant dip, that basically means you're not getting any marks for that test. So done then has to be a Boolean vertical bar. So done is Boolean, and this says so x is true, make done true. If x is false, leave done the way it is. What this means is done equals done or x greater than 10. Yeah, that's equivalent to that. Well, we don't know. So if done was true going in, then done is true. Oh wait, sorry, that's not true. So if done was false, then done is still false. If done was true, and this is false, then done is false. If this is true, then done stays true. All right, let's start back up. What I'd like to do now is take a brief diversion and develop a little bit of code, just as a coding example. So what I'm going to do is I'm going to develop a little program that moves a little car around in space. Now, I don't really want to do any sort of GUI anything, so we're not going to really have a car moving around on the screen. And we're certainly not going to have a real car moving around anywhere. But what I'm going to do is I'm going to create just a demo that has, that knows where a car is, moves it somewhere else, and then prints out where it is now. And what I'm going to do over the next few weeks is sort of build up this example to do something more interesting. So let's call it car demo. And I'm going to ignore the bit about not putting it in the default package. And I'm going to take this out. I'm going to take that nonsense out as well. Okay, car demo. And let's take this out too so we can have more room on screen. Okay, so NetBeans has generated a main for me, and now I just have to give it some content. So what I'm going to do is I'll have an X position and a Y position. So the car is going to move around on a map, and I'm just going to use integers to keep things simple. So I'm going to have an int X and an int Y, and those will hold the X and the Y coordinates of the car. And then I'm going to say system.out.println the car is at, and now I'm going to, print so the car is at, and then I'm going to print X, and then I'm going to put a comma between the two numbers. Let's say a comma and a space, and then there's the Y. And I need to close paren. Plus close paren. Whoops. What? Ah. Okay. So now I'm printing out what the position of the car is. What doesn't it like about X and Y? Okay, so one thing about NetBeans is it gives you some helpful variable information. If you just hover over this funny little light bulb. Light bulbs don't look like that anymore, do they? Anyway, if you hover over this Edison-era light bulb, it tells you what the problem is. So what it's telling me is that I haven't initialized X and I haven't initialized Y. Well, sure enough, I haven't. Where should we start X out? Shall we start it at 10? Let's not make it this X and Y the same. Make it a little easier to see what's going on. So let's start X out at 10 and Y out at 5. Okay, so now the program compiles, and let's run it. Is that main project? Demos. I don't actually, the default configuration is going to work. Okay, I've got a problem. Array index out of bounds exception. No, I'm not running the code. There's not a problem in this code. The problem is I need to configure. Yes, it's still running the other thing. Okay, let's say car demo. Okay, so I'm running the car demo now. Now it should print out the car is at 10.5. Okay, as expected. Now that's kind of boring. Let's move the car. So now let's Yeah, actually, let's do this. Let's have another variable, int dx. How far should I move it horizontally? And which direction? Shall we move southeast, maybe? Southeast would mean horizontally, I'm moving east, so that's positive. So let's move, say, 1, dx1, int dy, and let's have dy be -1, right? So south is going to be negative. I'm assuming the origin is in the lower left. So south is towards smaller numbers. Okay, so dy is -1. Okay, so now that hasn't done anything, but now what I want to say is, now I want to add dx to x. How should I do that? In braces or brackets? Square, curly braces like that? Parentheses, like that. And what do I want to write? Equals x plus dx. Oops, dx. Now what have I done? Dx. Okay, well, it doesn't like something about that. What do you think? You want to put it in here. Okay, it's happy now. And shall we do the same for y? So you notice I'm saying plus dy, but dy is negative. So, it's just convenient to always use plus and then let dy be negative or positive to indicate direction. Okay. And, well, let's just copy this over. In fact, I'm going to indent this. That's better. I'm going to copy this print statement out, or over. Nope. And I'll do another print after we do the, oops. Oh, come on. Didn't work. Try again. Edit. Copy. I'm sure I did Control C. Edit. Paste. There we go. Okay. And I'm going to say the car is now at. Okay. And now let's run it. And it says the car is at 10:05, and then it says the car is now at 11:04. So it worked. You notice before, it's gone away now. Okay, does anybody have any suggestions for ways to tighten up this code, make it a little bit nicer? These two statements can be tidied. Sorry?
X plus equals dx.
Right, exactly. X plus equals dx. So it's just a little shorter. And the thing about it is, it's not so much that it's shorter. It's that when you look at it, you can tell right away that you're changing x, that you're altering x. You're not just assigning x a new value. Okay, so I think that's a little nicer looking. And it does exactly the same thing. So that's sort of the first place where we've seen you can write better or worse code to do the same thing. There's nicer and not as nice ways to do things. This one's a little nicer. It's not a huge improvement. It's a little improvement. But you'll see as we go along, there's a lot more scope for doing things badly and well when we get a little more sophisticated. Okay, so any questions on that? Okay. So, formatted output. So, doing output with all these pluses everywhere is a little bit ugly. And what happens if you have a double, for example, holding a certain amount of money? You've done some calculations with it and you want to print it out. And it prints out maybe it prints it out as 3.0. It's $3. It's 3.0. It really, for money, it really should be 3.00, shouldn't it? And if it's $3.20, it's going to print out 3.2 instead of 3.20. You'd like to have more control over how these numbers are formatted. Also, if you're trying to print out a table of numbers, for example, you're printing out line after line after line, and you want them all to line up. Or in particular, if they're floating point numbers, you want the decimal points to line up. If they're integers, you want the right-hand sides to line up, not the left-hand sides. You want to have more control over the formatting. And that's where formatted output comes in. Now, Java has two ways of doing formatted output. There's the old way, and if you look through the textbook, it goes through great elaboration on how to use it. It really is treacherous. It really is painful. So my recommendation is just ignore that stuff. Maybe someday you'll come to the point where it gives you more sophisticated control that what I'm going to go over now doesn't give you. But this is so much easier. I'm just going to cover this, and I'm not going to expect you to know the other stuff for the exam. Okay, so there's a thing called printf, and you'd use it like system.out.printf, just where you would have said system.out.print or system.out.println. The thing is, printf lets you control the formatting. So the way it works is this. You do system.out.printf, and then the first argument is a format string. And then there's any number of other arguments after that, including 0. You could have 0. And what happens is the format string controls how all of these other arguments are printed out. Okay? So for example, here's a simple example, the sort of thing you might actually do. System.out.printf, and then your format string is average colon %5.2f end of string, comma, average. So you've got a variable called average, and it's going to be printed out using this format. Okay, now I'll go through how the format string is interpreted. So first of all, the format string is just a regular string, so you can do things like string concatenation, or you can build up that string any way you want. Most commonly, it's just a constant string like I've done here. But you can do more sophisticated things if you want. So inside the format string, it's just an ordinary string, and what happens is that string gets printed out, except there's special bits in there that say, now put the next argument in here. And the next format specifier says, now take the next argument and put that here. So in this case, I just had one format specifier. The format specifiers always begin with a % sign. So %5.2f, that whole thing is a format specifier. And that says, put the next argument here. The next argument being average. So it says average colon, and then it's going to put the average. Okay? Now, the format specifier, as I said, begins with a percent sign, and then sometimes, but not always, the next thing is a number. And that number controls how that next value is formatted. And then after the number, there's a format letter, a format specifier letter. And that format specifier letter tells you what type of thing the next argument is going to be. So F means a floating point number, either a double or a float. So average, in this case, that F tells you that average is a floating point, probably a double. And then, yeah, so as I suggested, the bits in the format string that are just regular text that aren't percent sign something, it just prints them out as they are. Okay, so now what are the, how do you interpret the number? So what you may have is number dot number, or you might just have number, or you might just have dot number. Okay, so let's take the first case, that if you have, well, let's look at the first thing. Before the dot, or if there is no dot, that specifies how much space, how many characters the next thing is going to take up. Actually, what it specifies is the minimum space it's going to take up. So in this example, this says we're going to print out on average, we're going to print out a number, and it's going to take up at least 5 spaces, at least 5 characters worth of space. And then note I said the minimum number. Whatever that number is, if it doesn't fit in that space, it's going to print out the whole number and just overflow that space. So it might take up more space, but it'll take up at least that much space. If it takes up less space, it'll pad it out with spaces on the left. Now, if you just have percent sign dot something, or you just have percent sign and then the letter immediately after it, you can do that too. You could just say percent %F. In that case, what it will do is it will print it out in the minimum width space. It won't put any spaces before it. It'll just print it out as is. Now, if you have percent minus something, then the first part of that number still tells you how big the space is. But now, if it needs to pad it out, if it needs to add extra spaces, it adds the extra space on the right. So it left justifies the number instead of right justifying. Okay, so you don't usually want that. You usually want your numbers right justified. But if you want left justified, you just use minus. And then the part after the decimal point doesn't apply to every type, but for a floating point number type, what it tells you is how many digits you're going to have after the decimal point. Okay, so, whoops. So 5.2F says we've got a space of 5, and there's 2 spaces after the decimal point. Okay, and so now, the final letter. What can the final letter be? Well, the final letter can be D, and that means decimal. So it's just going to print out an integer. And in that case, you don't want the fractional part, so no decimal point and no second number. So you can just have %D, or you can have %10D, or whatever you want. S means a string, and again, no fractional part. So in the case of a string, you might want to right justify it, or you might want to left justify it. So if you want to left justify it, it's % minus 50s or something like that. And that will left justify it. C is a character, so it's just going to print a single character. Well, in the case of a single character, you know it's only going to print out one character, but you can still say %5C, and then it's just going to do 4 spaces and then the character. %F means a floating point or a float or a double. And %E means print it out with exponential notation. 3.4E5, something like that. And then G is a special one. It says either do %F or %E, whichever can present the number in less space. But basically, it leaves it up to Java to choose which notation is preferable. So if the number is, not too big, then it'll pick F. If it's a really big number or a really tiny number, then it'll use exponential notation. And then a couple of special ones. So you might, once again, be wondering, so what if I want to put a % sign in my format string? I just want a % sign to come out. Well, you write %%. So %% tells Java that this % is not a format anything. This is just a % sign. So if you want to write 20%, you might write something like say 4D %%, and then the number. And then it'll print out the number and a % sign right after it. And then last one is %n is the same as \n. So to tell you the truth, I'm not sure why they bothered to put this in, because you can always just use \n. But %n is the same as \n. Okay, so those are the format letters. And so now, right, so here's an example. So I've got string S is the string, double pi is something approximating pi. And now I'll print out so this is a printf again. So I'll print out a quote character, %S, another quote character, has %D characters in it, %N. And now here's S, so that's the string. S.length, that's the %D. And then I'll print out pi to 4 places is %.4F %N. And I'll print out pi. And then here I'm saying write %9.4F. So I'm printing pi to 4 places in a field of 9. And it's a +9. There's no minus sign there. So it's going to be right justified. And then here's a left justified version where it's in a field of 9, but right justified. Okay, and here's the output. So a string has 6 characters, pi to 4 places, 3.1416. You notice it's not 3.1415, so when it runs out of space, it rounds the next digit. It doesn't truncate. Okay, which is what you'd want. All right? All right, so here's a little poll before I put this up. Let's start it. Okay. So everybody remember the magic URL? bit.ly/Shakti, SCHACHTE. So here's the question. How many characters appear before the decimal point in the number x if I print it out with printf percent 6.2F. All right, anybody want more time? Let's see what everybody has said. Okay, quite a few people saying E, 6. Then the next most popular answer is I don't know. And then the next most popular answer is 4, and then 3, and then 2. Okay. So let's see what the right answer is. The right answer is I don't know. So now the question is, how many of you got it right because you realized that you don't know the answer, and how many people you got it right because you just thought that was cute to put? So why don't you know? Okay, it's only the minimum number. Right? It depends on what X is. I didn't tell you what X is. If I told you, you could answer it. But X could be trillions. X could be a long. Oh. No, sorry, not a long. It's a double. So, yeah, it could be 10 to the 300. It could take 300 digits to print out. It's going to print out the whole number. Okay, so suppose it's small. Suppose X is 15.2. Then how many digits are going to appear before the decimal point? Before the decimal point. It's not 6, and it's not 2. It's 3. Okay? So you've got a space of 6. You've got a space of 6. On screen, yes. Then we're going to have 2 spaces before the decimal point. I don't know what they are. Then we're going to have the decimal point. That leaves 3. 2 after the decimal point, because that's what the, oh, well, now you can't see anything. Off. So that's what the 0.2 means. There's 2 spaces after the decimal point, and then, of course, there's 1 for the decimal point itself. So 2 from 6 is 4. 1 more for the decimal point leaves 3. Okay? So the right answer is still I don't know, but for a small number. The people who said 3 weren't too far wrong. Under the right conditions, that's the right answer. 4 could be the right answer. 6 could be the right answer, depending on the number. But The best answers to this are A and C. Okay, so now what I wanted to do, how am I doing for time? I'm okay-ish. This is kind of ugly, this bit here where I'm saying println, the car is at, and then an open paren, and then a plus, and then it's kind of ugly. What if I wanted to use printf to do it instead? So I only get one format string, so all of this stuff has to go in it. But I can just say the car is at %d, comma, space, %d, close paren, comma. I can get rid of that plus. In fact, let's get rid of the whole thing. It'd be easier to retype it. X comma Y. Too easy. There's actually something wrong with this. Anybody see what it is? It's not quite the same as it was before. There's one thing left out. Anybody? Sorry? New line. Yes, exactly. I need a new line at the end. All right, let's do %n. And, well, let's just copy this over. And this, by the way, is really bad practice. What you see me doing here, copying and pasting, I will later tell you that copy and paste programming is evil. But for the moment, I'm doing it because I haven't taught you how to do any of the great things you can do to avoid doing it. The car is now at, okay. Make that smaller. Oh, I can. Isn't that nice? Okay, so now I can run it, and it should do the same thing it did before. Okay? But with printf, you see, it's just nicer, isn't it? It's just a lot easier to read. Okay. Next thing, handling the command line. So you remember your main begins public static void main, open paren, string, open bracket, close bracket, args. Now we're going to talk about args. Args is the name of the command line inputs to your program. So when you run your program on the, from the shell command line, or in the GUI, you can specify what the command line inputs are. Your program has access to those inputs and can use them for stuff. So each of the command line inputs is a string. Okay, it's coming from the operating system. It's just coming from as a string. The operating system doesn't know how it's supposed to interpret, which things are numbers, which things are anything. So everything is just a string. So the first command line input is args of 0. The second is args of 1. The third is args of 2, and so on. So we're going to explain what this notation means with the square brackets and the numbers later. But for now, just take it as that. I mean, you see the pattern, just follow the pattern. You can handle as many command line inputs as you want. And later we'll understand what that means, and you can do more stuff with it. So you can have a friendly greeting that says hello and asks on the command line, or expects from the command line to be told the name of the person that is being greeted. So I can say system.out.println hello plus args of 0 plus exclamation point. And if I run it like this, Java hello to Peter, it says hello Peter. If I run it like this without any command line inputs, then I get this. Not very friendly message. So this has to do with arrays. We haven't talked about arrays yet. That's what the square bracket stuff is about. We'll come to that in a few weeks. For now, I'm just going to show you what message you get if you run a program that expects command line inputs and you don't specify the command line inputs. When you'll see for a lot of the, for most of the project submissions, for the project submission and for the assessed labs, almost all of them expect command line inputs. So if your program isn't doing the right thing, one place that you might have gone wrong is not handling the command line inputs. Yeah, that's one easy way to go wrong. So that's all well and good, but what happens if your command line input is supposed to be a number and you want to do some maths with it or something like that? How do you do that? Well, the answer is you need to convert from a string to an integer. So all the command line inputs come in as strings, always. If it is an integer and you want to treat it as an integer, you have to explicitly convert it. Java won't do that conversion for you. And the way you do the conversion, you can't do it by casting. Java won't let you do that. You have to do it explicitly, and you have to use this special operation. You say integer, notice the capital I, integer dot parse int, again another capital I. And so it's integer dot parse int, not integer dot parse integer or int dot parse int. Why they've made this confusion, who knows what they were smoking at the time. Anyway, integer dot parse int, and then you give it a string, and that returns an integer, and that's it. That's all you do. So if I've got another hello, it's not really much of a hello, but anyway, it reads a command line, a number from the command line, and prints out double it. And the reason I double it is just to show you that it really is an integer. So I say twice your number is, and then plus. So again, that's concatenation. 2 times integer dot parse int of args of 0. So the first command line input, I'm going to turn it into an integer, or to an int, I should say, and then multiply by 2. Now, here's a little aside for you. Why does this work? Why didn't it print out twice your number is 2 and then your integer? Why didn't it print out your, twice your number is 2, 4? The way it did when I said 1 plus 1 equals, and then plus 1 plus 1. I'm sorry? Exactly. Multiplication takes precedence. So times is higher precedence than plus. So the Java always puts the parens in for you. It has to put them in somewhere. It has to know how to interpret it. And so it puts in the parens implicitly around 2 times. If I'd put in explicit parentheses, it would work just fine, but I didn't need to because times has higher precedence than plus. Okay? So that's how you convert numbers to integers. You'll note that for your assessed lab due next week, you're going to need to do that. Right, where am I? 23. Yes. Okay, so now let's try something else over here. Okay. So we've got this delta x and delta y. I've just specified 1 and minus 1. Let's take them on the command line. Makes the program a little, all this program does is prints the same thing every time. It would be nice if it did something different with different inputs. So let's not do this. Let's let dx be the integer version of the first command line argument. How do I do that? So the first command line argument is going to be, let's say, 1, or maybe 3, or who knows what I'm going to put in. I want to get that as a, it's a string. I want to get that from a string. I want to turn it into an integer so I can put it in this variable dx. So down here I can do arithmetic with it. How do I do that? Sorry? Scanner. Okay, good answer, but wrong. Thanks for reminding me. The scanner is something completely different. So the command line is one thing. The command line is, well, like I showed you, whoops, hello. Like I showed you here, the command line is what happens when you run the program. You specify those on the line when you start to run the program. It's not being read from the console. You're not typing it in. You still are typing it in. You're typing it to the operating system. You're not typing it into the program. Okay? When you do console input, when you use this scanner, which we're going to come to in a minute, then your Java program is reading from the console. When you're taking arguments on the command line like this, then your Java program wakes up and it's given those things for free. It doesn't have to go out and read them. Okay? So that's a really important distinction, and thank you for reminding me, because I always forget to say it, but a lot of students make that confusion. And I'll give you a hint. You don't need to use the scanner for the first assessed lab. Okay? If you find yourself using the scanner, your program's not going to work, because I'm going to be giving you the command line arguments when I test your program. I'm going to be giving you the inputs that you need on the command line, like this. And then you're going to go off and try to read them. And there's nothing to read, because I'm not supplying anything to read. Okay? So completely different things. Reading from the console is completely different from arguments on the command line. I'll come to the reading from the console in a minute, and then hopefully that'll make it clearer. But anyway, so no, we don't want to use the console, the scanner for this. We want to replace this with something. Oops, no, I did the wrong thing. I want to replace this with something that's going to get that first command line argument, turn it into a number, turn it into an integer. Sorry? Integer dot parse int. You notice, by the way, that the IDE is sort of giving me hints, so that can save you some typing. And so now it wants a string. What string do I want to give it? arg0, right. Okay, and then what do I do here? Sorry?
Change the 0 to 1.
Yes, exactly. Change the 0 to 1. So I'm going to copy that, paste that, change the 0 to a 1. And now, what happens if I run it? Exactly. I'm going to get an array out of bounds exception because I haven't changed my inputs. So, so what I showed you before was how you specify command line arguments if you run it from the console. If you run it in an IDE, as I'm doing here, well, it depends on which IDE you're using. In the case of NetBeans, you do it here. It says arguments, car demo, arguments. So let's make it 2 minus 4. Okay. In Eclipse, by the way, the arguments are on separate lines. Each argument is its own input string thing. but in NetBeans it's all together. So there you go. So 2 minus 4 takes us from 10.5 to 12.1. So it works. Okay? Any questions on that? Okay. Console input. Okay, so reading the console input. So as of Java 5, the easiest way to do that is using the scanner class. To use the scanner class at all, you have to do an extra thing. You have to go up to the top of your file, very top of your file. You can have comments before it, but before you come to the class, the public class, whatever, you have to put this line, just exactly like this. Import java.util.scanner. Okay, if you don't do that, the IDE will probably tell you, remind you. And then you do this. Somewhere in your main, near the top, you say scanner keyboard equals new scanner system.in. So remember, system.out is what we're printing out to. System.in refers to your keyboard. And when you create a scanner and pass your keyboard input stream, it creates this scanner for you. Okay? So this creates a variable called keyboard that then we can use to read from the keyboard. And to use, the simplest way to use it is to say keyboard.nextLine, open paren, close paren. And what that does is whatever is the next whole line from the keyboard is returned. And in this case, it's going to be put into the variable line. Okay? There's some other ones that are useful. There's keyboard.next. What that does is it reads one word. And there's keyboard.nextInt that reads one word that's supposed to be a number, and it turns it into a number. So nextInt returns an int, whereas next returns a string. They both read the same amount of stuff, but nextInt returns it as an int, next returns it as a string. And there's also keyboard.nextDouble that'll return a double, and there's other versions for other sizes, but let's not bother about them. So all of these skip over white space. So if you type, you call nextInt, and you type, space 3.5. Oh no, you better say 35. Let's make it 35. Space 35. You'll just get back 35. It'll skip over the white space. It doesn't skip over white space after the thing, after the number. So the next time you read another number, it'll skip over the white space. And also, white space includes new lines. So if you call nextInt and then call nextInt again, it'll read them on the same line separated by spaces, or on two separate lines, or separated by a bunch of spaces and a bunch of lines. It'll still read them. And then, of course, it's an error if you write ABCD and call nextInt. It's not an int. What could it possibly return? Okay, so here's an example. You call integer.parseInt. Yeah. I think there's a problem with this. How does this even work? Oh. Yeah. Right, okay, sorry. My bad. So this is illustrating the difference between command line arguments and the scanner. So here I'm saying integer.parseInt args of 0. That's a command line argument. Now I'm going to open the scanner, create the scanner, and now I'm going to print out enter second number, and then I'll do keyboard.nextInt. So that's going to read a number from the keyboard. And then I'm going to print out the sum of the two. So I say Java scanner example 6, and then it prints out enter second number.